Okay, and I have a solve Leetcode number 323, number of connected components. Basically, you know, my question is on my certain number of nodes, variable nodes, right? ABR and my edges, right? Edges is just like directions, lengths between each node. Find the number of connected components, right? The connected components need to be a way connected way. And finally say, example your mama say, normal say n is equal to 5, which means nodes never near 5. And my components, edges, right? Edges 0, 1. My edges 1, 2. Now my edge 3, 4. Right? Into in fact say node 0 way connected to node 1. Node 1 now is connected to node 2. Right? Now my node 3 to connected to node 4. Node 3 to node 4. Or share the number of connected components, right? Yeah. Way 0 connected to 1, 1 connected to 2. And a way, you know, a man cassette is going in any direction, bi-directional, right? Which may if you 1 equal 0, which may if you 0 equal 1. But basically, you know, we a jam back and I will soon quite jam back. Another example, so on my end, so they say we are 0, 1, 1, 2, 2, 3, 3, 4. Right? And we say the way to my representing is say, and finally say 0 call 1. Right? 1 call 2, 2 call 3, 3 call 4. Right? Into the yakase the number of connected components. We a back component back up, right? Because wait me fear wait ma kwa. But we the component near 1 no ufia na kwa aka asa. Oba we are not ba say ufia so no kwa say. And basically no is just graph traversals, right? And basically question where a graph traversal question. A bi-directional graph traversal question. With graph traversals, no, you can either use a DFS or BFS, right? But we are my edges and the components. First, you're converting it to an adjacency list. And also have no video on adjacency list, so you can look at that. Converting into adjacency list, then you traverse the adjacency list using DFS and I say BFS. Yes or no, and know what kind the number of traversals that you get, because we say no. Then finally say 90 ways no asa, right? But we will find out do asa, but still numbers need be better. It is still I saw call into no when you 1 ubenya 1 osan be ye we bioma no when you 2 ufia ko kan ma no when you 2. In the number of traversals how be no and no never count the number of connected nodes exist. Where do you back up? But as you already know, you keep record of any node be able visit TB and so keep a record. And yes, we'll go through sir. But let's go and see how we can solve question. First, form an adjacency matrix. Into your friend a graph, right? Adjacency list. So your friend a graph, a default date. Lists, right? Into for each x, y in edges. Graph X append Y, and graph Y append X. Right, this is here and here for me adjacency listen. The next thing now you say is here that we have our adjacency list. Let's do our BFS traversal. ZBI BFS to take in a node variable. Right, you better set it up Q. Q is equal to the Q. It's a node. Q dot append node 9 is our kind of right, while Q node is equal to Q dot pop left for each neighbor in graph node if node not visited. So we are setting up variable, we are setting up results, right? Results is equal to 0, and I visited, and so actually visited and not seen in your visited is equal to sets. Okay, so if not in seen, seen dot add neighbor and a Q dot append neighbor. When just say who BBR, I see the council, we have visited that one, or we are right? It has been seen, it has been looked at, and I see you know. But yeah, they can't visited no. Yeah, they can't see no, right? So that yes, I'm baby. Yes, a record circle and circle and circle. We keep record of maybe I have a city here. So now you name set nodes near 5. Into for every node be an you better run it BFS on it, right? Into when say node be ever run BFS. But you run BFS now first you better check it versus sin now you say ya bad that see ya bad that we just forget about it. But see ya buy the eye the can Q no ho now as I record ya sin, right? Into you know basically what you for every node in range and if node not in scene BFS node. Now results near other one. Here we just return the results. So this is how we solve number of connected graphs. Okay, so what did I miss here? For node in range, no, if node not in scene. For kilo pop left. For neighbor in node. If node not in scene, Q dot append neighbor. Oh, my messy way. So I say no, if neighbor not insane, right? We're checking the neighbor, not the node. So that was the mistake here. So neighbor, and then I will say yeah, mature node. That's why it was wrong. Okay, but yeah, that's how you solve a question like this. All right, thank you, Rebecca Setri.